Certificates are not important in engineering and construction, skills and knowledge are. Today we look at the different grades of concrete and how you can achieve them. So let's get into it. Hello everyone. Okay, in the previous tutorial we saw the different grades of concrete. So today we are going to be looking at how you can achieve those different grades of concrete on site. We'll be looking at that looking at the two different types of mixtures that we commonly do on site, which is what the nominal mix and the design mix, and we'll see the differences and why it is preferable to use the design mix instead of the nominal mix, which is what we always use. I know 95% of everybody uses nominal mix, but it is preferable to use the design mix on site. So let's get into it. So let's say you are working with a grade of concrete, or you wish to achieve a grade of concrete of M20, and we all know that M20 constitutes of 1 part of cement to 1.5 parts of sand to 3 parts of aggregate. Okay, so this is for cement, this is for sand, and this is for the aggregate. Okay, so what this means is if you were to take 1 kilogram of cement and you mix with 1.5 kilograms of sand and you mix with 3 kilograms of aggregate, you are going to have the mixture of M20. Okay, so if we're working in terms of the bags of cement, so this means if you take 1 bag of cement, which is 50 kilograms, and you mix, you are going to be expected to have 75 kilograms of sand, and of course 150 kilograms of aggregate. Okay, you mix this in this proportion and you are going to have the grade of concrete, which is what? M20. Okay, now this is just for M20. So alternatively, let's say this is cement, sand, and aggregate. We also have different grades of concrete. We have, let's start from M10. We have M15. We have M20, which we are looking at right now. And of course, we have M25, and the list continues. Okay, so for M10, you have to mix 1 part of cement. Now, of course, it's always 1 part. Okay, it's always 1 part, as well as 3 parts of sand and 6 parts of aggregate. Okay, now for M15, you mix 1 part of cement and you mix 2 parts of sand and 4 parts of aggregate. Okay, now for M20, which is what we're looking at, you mix 1 part of cement, 1.5 parts of sand, and 3 parts of aggregate. And for M25, you mix 1 part of cement, 1 part of sand, 2 parts of aggregate. Now, what will you notice? You're going to notice that the ratio of cement to aggregate doubles. Okay, the ratio of cement to aggregate, it doubles. So you see, you have 3 parts of sand here. The ratio of sand to aggregate, rather, you have 3 parts of sand and you have 6 parts of aggregate, 2 parts of sand, 4 parts of aggregate. And of course, you can also see as it goes down that the ratio always doubles, but cement always remains the same. Okay, now here is the thing. If you were to mix this in these ratios, it is true that according to the nominal mix, because what you'll be doing here is what we call a nominal mix, you're going to attain this grades of concrete. But the thing is, it says nothing about the properties. What do I mean? The properties of these materials matters a lot. It doesn't mean that every time you mix this with this in this ratio, you are really accurately going to have this M20, because the properties also matter. That is why we have the design mix. Okay, because let's take, for instance, you have the cement. You know, we have different types of cement or different grades of cement, and those grades, they matter in terms of the strength, you know, and the properties and all that. Same with the sand, same with the aggregate. Okay, you have different types of sand, you have different types of aggregates, different sizes and stuff like that. All those have a lot to play as far as the final mixture is concerned. So if you were on site and you just have the attitude of mixing this in proportion without really taking into consideration the properties, then you are just going to be limiting yourself to the nominal mix, which is not really good. Okay, so what you should focus on is the design mix, and the design mix takes into consideration all of this, but it looks at the properties of the different types of materials. Like for instance, you know, like let's say for cement, we have different types of cement, You have Dangote, you have Robust, you have Cementcam, you have, and not only that, you have different qualities. You have cements that are of a 32.5. Okay, now that's the grade, and you also have 42.5. You know, that's the grade. So it doesn't just mean that when you want to mix cement, you just take any type of cement without really knowing the grade and stuff like that. So these are things which you have to take into consideration before you actually mix this. And secondly, for the design mix is more economical. The design mix is more economical than the nominal mix. Why? Because when you take into consideration the different properties of these materials, you are going to end up having a more economical mix. Let me explain that. When you're working with a nominal mix, you're like a robot, okay? You just know that, okay, no, for me to have M10 grade of concrete, I have to mix these different properties in this proportion, and I have my M10, M15, you know, and stuff like that. But there comes a situation where after calculating or looking at the different properties of the material, instead of having one part of cement, 1.5 parts of sand, and 3 parts of aggregate, you might end up having still to achieve M20, you might end up still to achieve M20, you might end up having maybe 1 part of cement, is 2 parts of sand, and 4 parts of aggregate, and which is still the design for, which is still the grade of M15, but you can still achieve M20. You're looking at the properties of the material that is after you've calculated everything that is in the design mix phase, and you can still achieve M20 using this if the properties of the materials are good. Yes, because the design mix relies solely on the properties of the materials. Okay, the design mix relies solely the properties of the materials to be used. Okay, and so if you want to look at the properties, you are going to see that at the end of the day, you are going to be having lesser volume of materials as compared to the nominal mix, because the nominal mix has just a fixed number, which you always just use because you just like, okay, yeah, M10, this is what I have to mix, M15, this is, you know, and stuff like that. It doesn't have anything to do with the properties, which is what it is mostly always done on site, but it is good to always have the design mix, because the design mix relies on the properties of the materials, like the properties of the cement, because you can bear with me that you can't be using 32.5 cement and you use 42.5 and you want to tell me that you're, at the end of the day, you're going to have the same grade of concrete. It is not possible. Okay, so if you're using a higher grade of cement, you might want to like maybe readjust the properties here, because this is what happens. As this grade of cement keeps going up, the volume of cement, the grade of concrete keeps going up, the volume of cement that you use increases. Okay, the volume of cement that you are going to use here, with the quantity of cement that you use for M10, is far less than the quantity of cement that you use in maybe achieving M20 or M25 and so on. Okay, so if you were to adjust, say after looking at your properties and you finally discover that, okay, instead of using M20, which is 1:1.5, which and to 3, I can still use 1:1.8 to 3. Whatever is happening, as long as you're able to accurately calculate and confirm that, no, okay, this is what it's going to do, and you are able to increase maybe, say, the quantity of the sand or the aggregate, then you are going to end up having, of which you can still achieve the grade of concrete, say maybe M20, then you are still on the right track. Okay, but in order for you to achieve this design mix, you must of course get the accurate properties of the different materials which you are using, which is the cement, the sand, and the aggregate. You put all those properties together, and then you are going to end up having still a very good mix, which is far more economical than just going for the nominal mix, because with the nominal mix, you are just going straight to the point. Okay, you don't do any calculations, you just go straight to the point. But it is always good to go for the design mix, because first it's economical, and then secondly, it is also more strong, you know, in terms of the strength as compared to the nominal mix, which is what a lot of the people use on their projects and stuff like that. Okay, All right, so that is just the difference between the nominal mix and the design mix. And I choose to do this video because I just wanted to differentiate the two and to also make sure that you always go for the design mix and not the nominal mix. Now, of course, for engineers, there is a graph that engineers use, which you can easily interpret to get the design mix, but you can have, from what I've been explaining, you can easily tell which grade or which mix is also good and how to achieve it. Okay. So that is it for this tutorial. And if you keep enjoying this tutorial, always make sure you like and share them so that others can also benefit. And also liking this tutorial also helps to encourage us to produce more tutorials. If you have any questions, you can always leave them in the comment section. Thank you and see you in the next tutorial.